Thank you for joining us. The session is predominantly going to be about sharing some best practices and strategies on scaling MySQL workloads on cloud specifically, and some of those are on Azure. So quick introductions. So I'm Deepthi, based out of Seattle, product lead at Azure Database for MySQL.
Sai Kondapalli, and I'm a product manager as well for Azure Database for MySQL, based out of Seattle, Redmond. So, hope everyone's having a good conference.
So yeah, first up, we'll just quickly lay some foundations on one is the need and when to start taking actions on scaling workloads and the different strategies. We'll also end with a demo and code on automating some of the stuff. So yeah, I guess everybody here is aware that generally the need for scaling is a positive problem to have. It's mostly that our applications grow over time, and it necessarily creates a non-optimal situation where the applications plus databases need to be scaled. And the other aspect is on the user side of things, where there's a huge surge or growth in the user base, which again needs some amount of scaling to match the demand. So the critical part of when to take action is all about monitoring. And generally what we have seen across majority of the customers that we work with as well is that there's heavy dependency on monitoring based on what the service necessarily provides. So for example, if you take on Azure, we provide something known as metrics. So those metrics are things like CPU, connections, IO, and few other basic metrics that is at an instance level and some at an InnoDB level as well. But I guess where majority of the customers fail to monitor their workloads well is make the most of the ecosystem that's provided. So it's like majority of the phone consumers don't use most of the features of the phone at all, right? So it's just a very small subset. So metrics from any managed service is just the tip of the iceberg. So but there are a whole lot of things, and possibly for the ones who are not well aware of the Azure ecosystem. So we have the biggest part or the main component is what we call as Azure Monitor. So this is a comprehensive monitoring system to collect, track, and even take actions on any data workload that you currently have. And metrics, as I mentioned, are the basic metrics of the database, and those get logged and can be accessed through monitor as well. And when you talk about cloud, there is this concept of availability. Is your database even up and running? Even though whether you can make connections or not, you need to also monitor what's happening with your say the instance. Is it currently available? So there are things like resource health, and for all the different kinds of logs, so slow query logs, server logs, and there are things like activity logs. So these are for things that are anything that's user generated, more or less. So let's say you manually even trigger a failover, or let's say there is an auto grow or auto scaling that's enabled. So if any action that happens on your database necessarily gets logged and is available through these activity logs as well. And workbooks is again just one form of visualization, because there are tons of logs that you can access, and you can even write custom scripts. You can even write like specific InnoDB queries, table queries, and get them logged on Azure Monitor. And workbooks is just a way of visualizing things, including Grafana. So there's also managed Grafana. So I think, and we see that that's not well used from a monitoring perspective. And it's like not just tracking your CPU or IO metrics or latency is not the only thing. And alerts, so these are like proactive push alerts that you can trigger, so in any way or format. So that's that, and we'll to go beyond, I think we'll quickly take a look at the architecture.
Yeah. So Deepthi has provided an overview on the different metrics monitoring capabilities available in Azure, and although don't want to directly jump into the scaling decisions that you have to take. So before that, just want to provide like a quick overview on Azure Database for MySQL. You may be acquainted with the product already, but if you're not, it's just going to provide you like a quick overview on what the service is and what are the capabilities, the integrations that come with Azure Database for MySQL. So Azure Database for MySQL Flexible Server is a fully managed PaaS offering from Azure, which runs community edition major versions of MySQL 5.7 and 8.0. So it provides customers with a bunch of capabilities, right? Where customers can control their maintenance windows, customizable maintenance windows, so that can cater to their application needs. Any unplanned maintenance windows that are out of customer control is not a really feasible thing, and that can cause a churn from the customer side. And moving forward, other aspects to deploying your database server in the cloud is also through security integration, the network isolations that you can provide for the database server. Of course, when you're talking about your tech stack, top to bottom, one of the main components for your application is where your data is residing. You don't want any malicious attacks on your database. So you want to secure your database altogether so that you are sure that only the provided resources are able to access the databases, such as coming from the application or someone from sysadmin team or a database admin team, right? So again, when you're deploying a resource database server, MySQL database server in Azure cloud, it doesn't mean that you only can get whatever is provided out of the box. There are customizations that you can do from a server parameter point of view, because we don't want to restrict customers to just use the defaults for each and every single server parameter out there. Every application behaves differently. Every application has a different need, and the way it performs the writes, the reads, how to configure the buffer pools, the change buffers, etc. So everything that you want to customize, you can do them through the server parameters, which are more or less the MySQL server parameters that you see in the community edition that are out there. And one other thing is that, when you're deploying your database servers, you are aiming for resiliency and availability. So you can do single zone deployment, multi-zone deployment for higher availability, so that, your databases are continually running despite there being any sort of, infrastructure issues, such as, any network drops, any host issues of that sort. And fully integrated with Azure ecosystem, so you can quickly integrate that with other services in Azure, so that you can quickly spin up an application and for a web application or something of that sort. A little bit deep dive into the flexible server architecture. So flexible server is based on a Linux virtual machine. So your MySQL is running on a Linux virtual machine with the storage being stored on what we call as premium file storage, where the data is replicated 3 times across the storage to provide maximal resiliency for the data that your applications are storing. Furthermore, as a customer, you can opt in for single zone or multi-zone deployment, so that you provide the higher availability, like I was just alluding to a bit ago. And we do take automated backups on a regular basis, and every few minutes we do also perform the bin log backup, so that you can perform point-in-time restore capabilities of such sort. And by default, we provide local redundancy backup storage, but for better resiliency of data, for disaster recovery as well, you can choose either zone redundant storage or geo redundant storage that can span across multiple physical regions across the globe, so that you can quickly recover from any sort of disasters, or you can conduct any disaster recovery tests as well. And with this architecture, customers do get the ability to co-locate the applications, so that you have minimal latency when your applications, where they are deployed in an availability zone or in a region, can talk to your database server with minimal latency to provide a better experience for your end users and the clients. Sure. So when it comes to tackling scaling, there are a bunch of things that you need to look at. The first aspect is the application optimization, and secondly, it's infrastructure solutions that we are going to discuss today, like vertical scaling and horizontal scaling. We'll not deep dive into application optimization as it is a bit of out of scope for us, and it falls more under how your applications are deployed, and you have to make any tweaks on the application side, such as any exponential backoffs that you have to configure on the application side, right? So we'll focus on vertical scaling and horizontal scaling today. So when it comes to vertical scaling, most of you are already aware since you are already running your database resources and how to tweak up and tweak down based on the application needs. Where we are trying to provide the ease of access for customers when running their databases in the cloud is through some of the optimizations and solutions that we are providing here, such as the storage auto growth, because you are sometimes some DBAs, some sysadmins are really good at forecasting the growth of the database. So based on that, they can appropriately take preemptive actions to set the proper storage size so that they do not run into any issues. But your application is just getting started and you don't have a full picture of what the forecast is going to look like. In such scenarios, storage auto grow will help out so that your application is not going into a blackout mode or a brownout mode, so that when it reaches a certain threshold, the storage will automatically grow to accommodate the writes that are coming into the database server. Similarly, on the IOPS side, there are a couple of capabilities when we are talking about Azure Database for MySQL. Well, some benchmarks do provide very reliable numbers to understand what the IOPS consumption is going to look like for a database server, right? But there are certain applications like a banking application or an e-commerce application where you do not know what the utilization is going to look like day to day, or whether that be week to week, or whether that could be a quarterly sales that is going on in an e-commerce application, or your banking application having tens of thousands of transactions during the business hours, which lasts for like 5 to 6 hours. But at the end of the day, you're probably utilizing only 10 to 20% of the IO utilization that is needed, and you don't want to pay that extra additional sum for that. So in which scenario, Autoscale IOPS comes into picture. It can provide consistent IOPS based on the application usage from a database point of view, and it can scale up or scale down the IOPS so that you're only paying for what you're using, rather than you are pre-provisioning tens of thousands of IOPS that you end up not using. And in vertical scaling, one other bottleneck that we do certainly see time to time is more or less from the compute side, the memory side, right? So your application can keep on growing, and a month ago or a year ago, whatever the CPU utilization was looking like, it may not be the same, because your data might have grown or your user base might have grown, which means that more and more application requests are coming to the database server. In which scenario you need to carefully consider whether I'm providing that ample room for my database server so that it can process the application transactions in a reliable, efficient manner without any latencies, because end experience matters for each and every single application. That's what we strive for, to provide the better experience for our customers. And this is where Azure Database for MySQL provides 3 compute classes. One is burstable, we have general purpose, and finally we have business critical. So burstable is more applicable in scenarios where you have any testing needs, or you want to run a very simple WordPress application where you don't want to have a consistent CPU or memory that is being available, and that only a certain customer base is going to hit the application, right? In coming to general purpose, more or less it caters to majority of the web applications that require consistent CPU, consistent memory, and you are aware of the application patterns, and you can necessarily take the actions on that. And finally, what we have is business critical, which is more or less for tier one enterprise workloads, such as any gaming, any fintech customers that can leverage anywhere between 2 core to up to 96 core. And the differentiating factor between a general purpose queue and a business critical queue is the amount of memory that is being available for each and every single compute core inside the virtual machine, right? So that is where any memory intensive applications do take advantage of, business critical queue, where a larger data set can reside in the memory. And yes, we are currently supporting up to 80,000 IOPS on business critical queue for all these larger enterprise mission critical applications. And the storage is currently supported for 20 to 16 terabytes, but we have 100 terabytes coming soon, which is in private preview.
Thanks, Sai. So I guess we covered some of the vertical scaling strategies on cloud that you can pursue. Again, moving on to the horizontal scaling. So here, I guess we'll start off with replication. I guess replication is possibly the most popular feature that's used across MySQL. And I guess there's also, I guess, that alludes to the native replication that's available across MySQL. And what we've tried to do that on cloud is to make it as easy and also scalable, not just from a scaling perspective, but also from a global reach perspective. So from a read-write separation point of view, so Azure provides a capability to create like one-click replicas, and these replicas can be in any given region. It can be in the same region as you've deployed. Again, it depends on the application's needs and necessities and what are you trying to resolve. So if it is mostly about also like read-write separation, we currently don't have an inbuilt capability, but I guess most commonly used like a lightweight proxy solution like proxy SQL can help even automate some of this replica creation and the scaling part of it. So we'll show a demo of how we could necessarily do that. But I guess that's one popular configuration that we've seen to also help enhance the write part of it by separating the read workloads. Then the other popular use case we've seen that necessarily helps scale out part of it is application scaling, where you can be near, or your applications can be near to where you're seeing your traffic coming in from. So that is available in two flavors. So one is cross-region read replication, which we have from a storage architecture perspective. But no matter any other region in the world, you can it's a managed capability that you will get. But that said, I know even though it's a managed database offering, I think one capability is you can also set up data in replication amongst any two servers that you necessarily want to be doing as well. Both binlog as well as GTID based replication. So that's on the read scale out. So we want to just showcase how you can make use of the cloud ecosystem, and it's not just that managed services are in black boxes. So those are black boxes for majority of the customers, but if there are power users, like we necessarily enable or even change or let them modify a lot of things. And so this is an example of making use of the cloud ecosystem to also help automate scaling. So for example, let's take a primary server. So that's this flexible server. And as we discussed earlier, there are a lot of monitoring metrics that are available today. And you can choose and configure what are the different metrics that you want to be tracking for monitoring your primary database. And what we've necessarily done and will take you through is we'll use a serverless application. So function app is a serverless application. So it will come into picture when there is a particular condition where you want to be taking action. So what we use in serverless is for both things. One is regular monitoring. So in this function app, what we do is every minute, we monitor the metrics that of the primary database, and then based on the conditions that you want for your respective databases, it can take action. So in the demo, what we'll do is we will track this for the number of active connections that are happening. When the connection volume goes above a certain limit, what this function app will do is it will trigger an automatic read replica creation. And if you also have a proxy solution like proxy SQL, what we will be able to also automate is get the connection strings of the read replica, go and modify the proxy SQL configuration so that the incoming workloads are automatically routed. So it's almost an end-to-end automated solution there. So let's jump to the code and quickly take a look.
Any questions so far in the meantime?
So this is a function app, but if most of you are familiar with VS Code, all you need to do is deploy a function app extension, and you will be able to create any number of serverless functions, as simple as go to command palette and create new functions as and when you want to be monitoring. So in this, I have used a timer trigger function. So I want this to periodically be running, but there are multiple ways. I'll show you on the portal the different, basically this is all like reactive programming, and you can choose what you want to be, how you want to be triggered, or how you want this function to be triggered. So here, this is a timer. It's similar to like a cron job. I've programmed this to run every minute. And every time this function gets triggered, so here what I'll be doing is connecting to the database, used Python as the language here. So the packages for connecting running queries. So the main part here that all of us need to take note is the concept of managed identity, because you need to give control to the function app or the serverless function to control and take actions on behalf of your database. So within Azure, we call that as managed identities. So you let other services within Azure take action on a particular resource. So if you can see, this is where I'm getting that token on behalf, and this token is what will drive majority of the identity capabilities. So again, one thing I wanted to showcase is, we are able to run queries. For example, here I'm basically running a MySQL query on the primary database. So getting the number of active connections. And based on the connection threshold, this will help create a resource. And again, making use of, like you can manage the resources through the managed identity again. So you say, hey, this is the identity, I want to go create it, and then it creates based on the template. So what we do here is get the details of the source server and use the same capabilities of the source server and trigger a replica on the particular source. So simple enough, but the critical part of it is handling the identity part of it. But you can run SQL queries, you can run CLI actions, you can do any resource management updates, anything and everything through the serverless function. So just to showcase, this is what a function app will look like. And as I mentioned, there are any different kinds of events that you can track. So yeah, you can use any kinds of triggers. This is like those Zapier or IFTTT, like if this then that kind of, but basically a reactive programming. And people who are familiar with Azure would know event hubs, where you necessarily track particular events. So different kinds of triggers And as I mentioned, yeah, so here's a timer trigger that I've used. Yeah, you could either do it through the portal way or through the coding way. So I just showed you through the VS Code way. Okay, I think internet, yeah. So in addition to the timer trigger, you can put in additional inputs as well, input parameters that you want to be driving. Yeah, in this current example, I have not. So I think any questions? If not, I'll just recorded the demo and I will run this. Can't seem to run it. Is it running? Okay. Yeah. So it's the same thing. We just start off with the empty slate where we just have a primary server and there are no replica that's currently set up. And yeah. Yeah. So there's no replication. Setting up the function app, which is again timer triggered. And there's continuous logging that's happening, so you can continue to check what's happening on your serverless function throughout. Yeah, we just went through this same code. Just for demo purposes, the threshold is set at 20. So anytime the connections, incoming or active connections go beyond 20, we trigger the function app. So currently it's at 15, and then we trigger additional connections. So the function app should have triggered now, since, so if you just go to the function app and yeah, it's getting deployed. It takes a few minutes to complete deployment, and at the end of it, there should be the replica. So yeah, it's more like infrastructure as code, even for maintainability and monitoring, also ensuring that the database is performant. And right now, if you look, yeah, there's this replica that gets created. So yeah. So this can be done for any kind of action, not just from a scaling perspective, but for failovers, promoting replicas to standalone servers, any of these actions. So this is just an example of that. Yeah, moving further on the,
Okay, so before diving into partitioning and sharding, the solution that Deepthi just depicted, more or less, it's not just an in-region solution. You can deploy it across regions as well. So functions can trigger these deployments, the read replicas across regions, so that you can support read scalability across different geographies for your applications that are spanning across the globe, just to make things a little bit easier and simpler, rather than manually taking a snapshot and then deploying all of that, manually configuring any sort of the replication functionality, such as the bin log positions, etc., right? So you can take advantage of that. And from a scaling point of view, let's also look at partitioning and sharding. So many of you are aware of how large tables are kind of in MySQL. And as the table keeps on growing, what happens is that it's tough from 2 points of view. One is the maintainability point of view, and the second is the the functionality of the table itself. Like, you cannot easily query, or easily you can perform any DMLs, DDLs against the table. So horizontal partitioning is where you can split your table into multiple parts, so that it becomes easier for your maintenance, as well as it provides better performance, right? So when we're talking about maintenance, it becomes easier for any DDL activities on individual partitions. And performance, I mean, when a query has to, fetch a record, it can, potentially fetch that record from one of the individual partition rather than, scanning through the table. So that becomes much more easier with partitioning on the right side of things. And this is more or less, supporting activities where, it's a little bit complex and tedious, where read replicas cannot fully provide you that solutioning, where partitioning will provide you with better performance for your writes and reads there. And finally, sharding. So in scenarios where the read replicas not able to handle the transactions for writes, and your primary server is still getting clogged with many number of writes. So in such scenarios, the only potential solution would be to move forward and split the database into multiple nodes, where parts of the databases are sitting on each of the different nodes to support the right aspects of the database. So for example, I mean, on a very large table in MySQL, you can potentially split it across multiple database nodes, like 1 to 1 million rows are sitting on shard 1, 1 million and 1 to 2 million are sitting on shard 2, so on and so forth, right? So that becomes much more easier. Of course, with sharding, we are also looking at potential functionality changes to the application, where the application should be aware of how to write the transaction and how to fetch the transactions. Solutions such as vitess can provide a bit of abstraction over there, making things a little bit easier from maintainability point of view, and also to reshard the database as you are growing more and more. So more or less accommodates large data sets and improves performance for writes, because every individual node can now process the writes, rather than one single database node doing all the writes, and the other database servers are doing the reads.
Yeah, that's all we had. Sure. So I think that's all we had for today. And so yeah, if you want to keep up to date with some of the additional enhancements that we are bringing in, you can follow us on any of the social handles that we have, or there's a one-stop shop with MySQL resources, so where we continue to update. But any questions, we are happy to answer. And
So
yeah.
some of the sharding functionality, is any of that built into the Azure ecosystem at this point in time?
No.
Okay.
Yeah, we don't support sharding per se, but as Sai was mentioning, the possibilities is, so let's say if you use a third-party sharding solution, you could deploy each shard as one flexible server on Azure. So
yeah, we conducted some internal proof of concepts around that, on how to, support some of these large customers who are coming up with requirements where, one single database node, whether that be like a 96 core machine with 800 GB of RAM, not being able to support the writes, right? So in those scenarios, yes, potentially, what is a feasible way? Of course, sharding is the only way moving forward for such, problematic scenarios for these applications, right? So we conducted an internal POC using Vitess, and we did, achieve the functionality of sharding through that. Vitess running on AKS pods, Kubernetes, or even on a Linux virtual machine can do that.
And generally, we also have a monthly webinar that happens second week of every month. So in case you have any additional questions, etc., or updates from the past month, we also continue to share that. Thank you.
Folks.